What's going on, peeps? Welcome back to science class. So we're going to be going over all the information that we've been going over for the past week now, except we're going to be talking just a little bit in more depth with a couple of topics. We've talked a lot about natural selection this past week, and if you're in class, we did a whole simulation on it. We mentioned artificial selection as well. Everyone read about artificial selection and natural selection in the active reading that we all did. And the last one that we didn't talk about is called sexual selection, which is when a species evolves over time because of sexual preferences within the species. So let's get going and talk about all three. I'll try to keep this relatively short for you guys. So, evolution and adaptation definitions. Let's go over some of the basics first. Definition of evolution. It is a change in the frequency of certain genes in the gene pool of a species over time. Another way to say this, it is just a gradual change in a species over time. The reason that species change over time is because their genes change. So that's why this is worded that way. An adaptation is a change in a gene caused by a random mutation that gives an organism a better chance to survive and reproduce. Okay? And an organism's fitness is all about not just their ability to survive, but also their ability to have more babies. Here are some major points of our modern theory of evolution. Variation exists within the gene pool of every species because of random mutations. We haven't really covered mutations yet in class. However, mutations are, one second. We haven't talked about mutations yet. However, we will. To give you a little short synopsis, though, a mutation is a change in your genes, and it's random and it's accidental. It's not supposed to happen; it just does. But it's a good thing that it does. Without random mutations, species would not evolve over time. And we're going to go over that as a whole lesson one day. Number two, in any given year, most species produce more offspring than can be supported by the ecosystem due to limited food sources and habitat. Number three, in a particular environment, some individuals of a species are better suited for survival than others due to their genetics. This is called fitness. This group of better adapted individuals has a greater chance of surviving long enough to reproduce successfully, and therefore they leave a higher average number of offspring behind. And numbers 2, 3, and 4 we've talked about in more depth already. Number 5, over time, the genes that account for organisms being more successful become more and more frequent because they are passed on more frequently. In other words, if, for example, this cheetah is one of the fastest cheetahs there are, and it's that way because of a gene it has, it's very likely to survive and have offspring and pass on that gene. So the likelihood that that gene is passed on is increased. A couple of misconceptions, which I've noticed some of you even have. A misconception, by the way, is something that you might think is true, but it's not. Misconception number 1, adaptations happen when organisms need them. That is not true. Misconception number 2, organisms can adapt during their lifetime. It's also not true. So, for example, even though it would be extremely what's the word I'm looking for? Convenient for a beaver to grow a hand that is actually a chainsaw, it's not going to make that mutation in its own lifetime. Also, it's not that's also not what's going to happen just because it would benefit the species. Um, what might happen in reality is the babies of some beavers might be born with a genetic mutation to make their teeth a little bit bigger, so a couple millimeters. And then that gene might be passed on again to other generations. And one generation, maybe there's another mutation and it makes their teeth just a little bit longer, maybe thicker too, maybe sharper. And then that is more useful. So that gene gets passed on. And then later down, years down the road, there's another mutation and it makes their teeth even longer and sharper and thicker. Eventually, the beavers with the longest and sharpest and thickest teeth end up doing better in their habitats, and so they pass on their genes more often than other beavers. Uh, you can go from having a beaver with very relatively short and dull teeth to generations later, a beaver with sharper, longer, and thicker teeth. Mutations are going to cause many differences between species, like all these birds on the right. Adaptations are random, caused by random mutations. These mutations are on accident. Um, if you get a random mutation and it helps you survive, then it might pass on to the next generation. You might get a mutation, or not you in your lifetime, but a new organism, a new baby organism might get a mutation that sucks and it's not going to help them and they're not going to pass on that gene because they don't survive. Um, so one thing to get from this is that getting a good mutation is random and it's like winning the lottery. It's not for any rhyme or reason. An organism just happened to be born with a good positive mutation. Um, Conception number 2. Organisms are born with their adaptations, which are caused by mutations in their gametes. Over many generations, more mutations may accumulate, producing change over time. So, yeah, you're not, what this is saying is that you're not going to change in your own lifetime, but an organism will be born with changes that are different from their parent. When you have a bunch of random mutations, um, you then get more species in the long term. So all of these different types of birds have a common ancestor, and there used to be one or like some one species of bird that eventually, over a long, long period of time, had babies, and some babies had uh, feet that were slightly webbed and they were better for swimming. Some babies had feet that were had long talons and they were better for catching prey, right? And all these random mutations that were created with these new baby birds made them better at what they do, and they passed that gene on. Eventually, you have many different species of birds, like in this picture. Some causes of evolution. You have natural selection, which we've been going over. Survival of the fittest. It's the process of which populations change in response to their environment. As individuals better adapted to their environment, leave more offspring due to survival of the fittest. And the inferior inherited characteristics are usually weeded out because they aren't going to be passed on as often. If you're born with a genetic mutation or characteristic that is not as good as others, you're probably going to die off in the animal world. In the human world, we take care of our sick and weak. Artificial selection is another agent of evolution. Artificial selection is evolution caused by human breeding. We choose to breed a certain trait. It's called selective breeding. It works faster than natural selection because there is much less of a chance that the organisms with less desirable traits will reproduce. Um, Perfect example are breeding dogs. If I want to breed a purebred pit bull that is gray, and I have other pit bulls, but I have a pit bull that's kind of like a charcoal, like a darker gray, another pit bull that's um, another kind of like white, and I have a bunch of other pit bulls that are gray. I'm not going to let the different colored pit bulls breed with my gray pit bulls because I want to artificially select which traits get passed on. In the case of food crops, it has led to a reduction in variation within a species because people tend to prefer a few variations of their fruits and vegetables, whereas in the wild, these plants, where they originally came from, there are usually hundreds of varieties. And so a lot of wild types of veggie crops are going extinct due to habitat loss. Um, so on the plus side, because of artificial selection, we've been able to only uh, only produce crops, apples, for example, that are the biggest, right? But if you found wild apples out in the on a forest somewhere, you'd probably find that apples are actually much smaller than you'd find in a store because the ones that you get from a store are artificially selected and bred to be bigger. When you lose variation in a gene pool of a species, it makes it harder for a species to adapt to a changing environment or a new disease. So, by getting rid of all these wild types of fruits and stuff, you are decreasing something called the biodiversity, which uh, it, in which then in turn decreases the variance of genes within the species, and it's possible that one of the genes that was weeded out could have been a gene that helped fight against a disease or adapt in a changing environment. So, artificial selection can be detrimental as well. And lastly, there's sexual selection. That is when traits are passed on because of the species' sexual preferences. Within peacocks, females are attracted to the male's feathers. So the males that end up passing on their genes are usually the males with the longest, most colorful, and biggest display of feathers. Same goes for deer and buck. Long horns seem to be a sexual preference for doe um, in deer populations. So, what would end up happening is the buck with the biggest horns, end up passing on their traits more than buck with smaller horns or less prongs. However, it could be detrimental in the long run. If through genetic mutations over generations and generations, a buck grows horns that are too big, it could decrease their chances of survival. And that's where we're going to stop today. Next, we're going to play a Kahoot to identify different different types of selection given a scenario. Okay.